Alright, now we're going to talk about two different types of plane now that we have these other vectors that we're using. So the first one, the definition, the plane determined by the normal and binormal vectors n and b at a point P on a curve C is called the normal plane. So the vectors, the normal and the binormal vectors are going to make up the normal plane. So hopefully that's easy to remember. And it consists of all lines that are orthogonal to the tangent vector t. So again, I'm just going to draw this for you real quick. So say, here's the curve. And we have our vectors. So here's the tangent vector. Here's the normal vector. And then, say there is the binormal vector. And again, that's going to just kind of come off on both sides that way. The plane right here is going to be the normal plane. This plane right there. Alright? And that's just going to contain all vectors that are going to be orthogonal to the tangent vector. So that is what would be called the normal plane. And so remember, when we're writing the equation of a normal plane, or in the equation of a plane, we want the vector that's orthogonal to be the vector that we're going to use when we're going to write the equation of the normal plane. So the tangent vector, or the unit tangent vector, would be the vector that we're going to use. Again, we don't have to use the unit tangent vector. We can use any vector as long as it's pointing in the correct direction. Now, so that's the normal plane. So when we're writing out the equation, what we really want is the vector r prime of t. We don't need the exact unit tangent vector. We just need a tangent vector, and r prime gives us that tangent vector. Then the next we have is the osculating vector. Right? And the osculating vector is the vector that's made up of t and n. And so that vector is, it's going to be a little bit more difficult to draw, is, I don't want to use red, would be like this vector. Where the vector that's going to be orthogonal to that would be the binormal vector, which stinks because now in order to find a vector to use for the equation of a plane, we have to find the binormal vector. In order to find the binormal vector, we have to find the normal vector, we have to find the tangent vector. So, finding the equation for an osculating plane is not going to be quick. And so it is going to take some time. So let's go ahead and not waste any more time explaining what we're doing and actually do it. So let's go ahead, and what we want to do is we want to find equations of the normal plane and oscillating plane of the curve at the given point. So now again, we need to find, okay, well, what's our point? Where are we at? When are we at? So we have t is equal to, so if x is equal to t, y is equal to t squared, z is equal to t cubed, and we get 1, 1, 1, it means t is equal to 1. Alright, when plugging in all these values for 1, we get 1, 1, 1. So now we need to write our vector equation, which is just t squared, and t cubed. Now that we have our t, if I want to, write the normal plane, the equation for the normal plane, it's not going to be that difficult. All I need to do is I need to take the derivative of r of t. And so that's what we're going to do. So taking the derivative of r of t, we're going to get r prime of t is equal to just 1, 2t, and 3t squared. Now, that is a tangent vector. It's not the unit tangent vector, but it is a tangent vector. And because it's a tangent vector, what I'm able to do now is I'm able to plug in for t. So I can say r prime of 1 and plug that into my vector. And so vector function, I get 1, 2, and 3. And so now at my point 1, 1, 1, I have a tangent vector 1, 2, 3. So therefore I can write my I can actually write the equation for my normal plane. And so to write that equation, I'm going to use my vectors. So x1 times x minus 1 plus 2 times y minus 1 plus 3 times z minus 1, and that all equals 0. Now just to show you that 1, 2, and 3 came from 1, 2, and 3 there, came from the tangent vector, and then my x minus 1, y minus 1, and z minus 1, they came from my point 1, 1, 1. And so what I'll do now, if my pencil died, and this is gonna be like, I'm gonna wait like 3 minutes to do it. So it's like, okay, on your own, now I want you to try tangent of t. Now, what's great about this is a video, so you can skip this little time just because my Apple Pencil died on me. And so, just use this time, get up, take a break, or, find the unit tangent vector on your own. Do what you gotta do. I'm just sorry if you stay on and you don't skip, 2 minutes ahead. You'll just listen to me talk. But yeah, so hopefully that's not too difficult for you, is to write the equation. So the normal plane isn't going to be bad at all, because you take the derivative of your vector function, and bam, you got a tangent vector. Plug in the value that we have, and boom, we got the equation for the normal plane. So yeah, that's not bad at all. The only thing, that stinks is we've got to do the osculating. We've got to do the osculating plane. So that means that we've got to find the normal plane. The normal vector and the binormal vector. So let's go ahead and do that. I think I've given enough time to finish this, but who knows? These problems take so long to do. And if you've had any family members take this class, oh, hey, wait till you get to binormal vectors. They're fun because they take all day to do. That's not necessarily what makes things fun. What makes things fun is it's difficult, but you get it. It's not fun when it's something that's easy, which this isn't too bad, but it's very easy to make a mistake. And I don't want you to make a mistake, so take your time. But it's very easy to make a mistake on here. But it's long, and you might not feel, too accomplished when you've done this, or when you complete it, you're like, I did all that for that. That's awesome. That's great. And you're not really meaning it's awesome or great. You're just like, it sounds like an awesome, like, yes, that was cool, awesome, that was great. But it's not that great, because it's a lot of work for, hey, there's my binormal vector. That's great. All right, let's see. So I'm going to check to make sure how much battery life. It says 20%, so we should be good. Alright, so now I'm at 20% for my Apple Pencil. So plus, I don't know how much erase, so it was plus 3z minus 1 is equal to 0. And then I can just put that into standard form, and I'm going to get x plus 2y plus 3z is equal to 1 plus 2 plus 3 is 6. All right. And so there is the first solution. All right. That is the equation for the normal plane. Now I need to find the equation of the osculating plane. So now this is why you have all this room right here. And so finding equations of the normal plane, osculating, also we got to find the tangent. So let's go ahead and find the unit tangent. So let's go ahead. I have tangent of t, and that's going to be equal to r prime of t over the magnitude of r prime of t. And so we have r prime of t, which is 1, 2, 2t, and 3t squared. So vector 1, 2t, 3t squared over r prime of t, which is just going to be the square root of 1 squared plus 2t squared plus 3t squared squared. And so we're just going to get 1, 2t, 3t squared all over the square root of 1 plus 4t squared plus 3, I'm going to go ahead and do that, 9t to the 4th. And there's really no simplifying that. So basically that's our unit tangent vector, all right? I'm going to rewrite this just so when we actually do the derivative of our unit tangent vector, you'll see the calculus, you'll see the differentiation and why I did it this way. So I'm going to rewrite this, because we have a square root in the denominator. I'm just going to say that's 1 plus 4t squared plus 9t to the 4th to the 1/2, negative 1/2 power, and then that's all multiplied by 1, 2t, and 3t squared. All right. Now, in order to get the normal vector, I need to take the derivative of this. So now I'm going to take the derivative of tangent of t, or the unit tangent. And so I'm going to hopefully denote all that, you'll be able to denote it. So what I'm going to do is I'm going to do the first one, and I'm going to do it in pink. I'm going to do it of 1. And I'm multiplying this 1 times all of that. So that's going to be the first vector. I'm going to take the derivative. So because I'm multiplying those two things, I'm going to show you the product rule. So the first thing I'm going to do is I'm going to take the derivative of 1. I'm going to take the derivative of 1, which is 0. So 0 times all of this is going to be 0. So that means that this vector is going to be 0, and then plus 1 times all of that. And it will times the derivative of all that. So now I'm going to multiply by negative 1/2. I'll put this in a bigger bracket. Keep all the stuff on the inside, so 1 plus 4t squared plus 9t to the 4th to the negative 3/2 times the derivative of the inside, which is going to be 0, 8t plus 36t. And that does it for the inside, plus 36t cubed. And that does it for the inside there. So that's going to be our first value. All right, now let's do the second. So instead of going, I'm just going to write underneath. So now the second component is I'm going to multiply 2t times all of that. And again, I'm going to start with 2t. So derivative of 2t is going to be just 2. So I have 2 times all that jazz over there, which is going to be 1 plus 4t squared plus 9t to the 4th to the negative 1/2. And then times 2t, so plus 2t, times the derivative of all that 1 plus 4t squared plus 9t to the 4th to the negative 1/2, which, you know, I've already done. So I'm just going to copy what I have up here. Negative 1/2, 1 plus 4t squared plus 9t to the 4th, negative 3/2 times 8t plus 36t cubed. Alright, and now let's do the last one, which is going to be very similar. Let me erase this because I don't really need that. Erase this too. And so now I'm going to multiply the last component times all that right there. And I'm going to get the derivative of 3t squared is just 6t. 1 plus 4t squared plus 9t to the 4th, negative 1/2, plus all that above. So we have 3t squared and then negative 1/2, 1 plus 4t squared plus 9t to the 4th, negative 3/2, 8t plus 36t cubed. Oh, don't need that comma because that's the end of the vector. Alright, so now what I'm going to do, I'm going to go ahead and pull out what I can to make this, you know, more simplified. So one thing I want to show you is that, you know, every single component has this part in it. All right, 1 plus 4t squared plus 9t to the 4th. Don't want to hear it. And so because I have that, what I'm going to do is I'm going to go ahead and pull all that out. All right, I'm going to pull that out. And so I'm going to get, let me go to this blue to represent everything. So I'm going to pull out a 1 plus 4t squared plus 9t to the 4th to the negative 3/2. Now, the thing is, you're like, oh, wait, Mr. Marcial, you know, what about, you know, this component in it right there and that component? Oh, it has something that looks very similar to it. Yes, but it has negative 1/2, not negative 3/2. Well, if I pull out that negative 3/2, what's going to happen is that I'm actually just going to be able to get one of those, you know, one whole one in kind of the numerator. And so that's just some algebra. So now I'm going to go ahead and write my vectors. And on top, what's left is just going to be negative 1/2 times 8t plus 36t. So I'll write that out. Negative 1/2 8t plus 36t cubed. And then I have a 2 times 1 plus 4t squared plus 9t to the 4th. And because I pulled out negative 3/2 and there's only a negative 1/2 there, I'm able to keep everything there. Then I have a plus 2t times negative 1/2 8t plus 36t cubed. And then my last one, I'm able to have a 6t a 6t plus a 3t squared times negative 1/2, and then 8t plus 36t cubed. And now let's combine everything in there. I'm just going to simplify. You kind of really don't have to, because we have, what we need, but I'm going to go ahead and simplify. And I'll show you after I've simplified this. So 1 plus 4t squared plus 9t to the 4th, negative 3/2, and then simplify. So negative 1/2 into 8 and 36 is just going to give me negative 4t minus 36 divided by 2 is 18t cubed. Again, I want to check my work just to make sure I have everything. And then the next one, so I'm going to multiply 2 times 1 plus 4t squared plus 9t to the 4th. So I have 2 plus 8t squared plus 9t to the 4th. So that's going to give me 2. I want to do everything in my head right now. So that's the only value it's going to give me. It's going to be a 2. 8t squared. 8t squared minus 8t squared is going to be 0, so that goes away. And then 18t to the 4th minus 36t, so minus 18t to the make sure and check my work. That's just going to be t to the 4th, 18t to the 4th, so 2 negative 1/2, so minus 8, so minus 36t cubed plus 18t to the 4th. And then finally, we'll do the last one, which is 6t. It's the only one that's going to give me a 6t. And it looks like I've forgotten to write something for this one. So that's 1 plus 4t squared plus 9t to the 4th times that 6t. So that's fun. So 1 times 6t is 6t. Then we have 6t times 4t squared, so it's going to be 24t cubed. I'm going to have any t cubes over here? Yes, 24t cubed. 8 times 9, so negative 4t, negative 12, so plus 12t cubed. Then 9t to the 4th. 9 times 6 is 54t to the 5th plus 54t to the 5th. And then 18, let's see, half of that's 18, 36, and the 18 is going to be 54t to the 5th. So minus 54t to the 5th. And so that's just going to go away. And that's what I'm left with. Alright, so that's my tangent vector. Do I need the unit tangent vector? I don't need the unit tangent vector. All I need is just a tangent vector. So when I find my normal vector, all I'm going to do is I'm going to substitute everything in. And so again, for my normal vector, it's just the unit tangent vector, the derivative of that over the unit tangent vector, the magnitude of that. But we're just going to find it at 0. So when we do this, we're going to get n of 0. Is equal to, so I'm going to substitute in 0, and I'm going to get, when I plug in 0 for these values right here, I'm just going to get 1. So therefore, I have 1 times -4 minus 18, so that's going to be -22. 2 minus 36 plus 18, so that's going to give me 20, so 16, -16. And then plug in again 0, and I get, I'm sorry, not 0, but 1. I get 6 plus 12, which is 18. And dividing that by, I plug in, and I'm just going to get the same thing, but I'm going to get -22 squared -22 square, I'm sorry, plus -16 squared plus 18 squared, all over 1 squared, and that 1, of course, is coming from this part, but in the denominator. And the thing about all of this, everything that we're going to be getting here for the unit normal, we just need a vector. We don't need the unit normal. We just need an n of, we just need this same direction. So all I need to do is just make sure that I take my vector, which is right here, and that's all I need. All I need is that vector, because everything else is just going to be the unit, and I just need to be pointing in that direction. So that's going to be something that's perpendicular. And because I just need something that's going to be similar to that, I don't even need to take this, because I notice, oh, hey, there's a number that goes into all those values too. So what I can use for my normal vector is just -11, -8, and 9. So that's what I'm going to use for my normal vector. Alright. So now, what I'm going to go ahead and do is multiply my n of 1, and that should say 1, not 0. Times my tangent of 1, and I'm going to be getting negative 11, negative 8, and 9 times unit normal, which was 1, 2, which I can just use as 1, 2, 3. 1, 2, 3. This is just coming from what I used previously from right there, because that's a tangent vector. Alright, so multiplying a normal vector, not the unit normal, just a normal vector times a tangent vector, not the unit tangent vector. And now that I have this, I can go ahead and do the cross product, and so I'll multiply, and I'm going to get negative 8 times 3, which is negative 24, minus 18. Then I can do negative 11 times 3, put a negative in front, so it's going to be negative 33 minus 9. And then I have negative 11 times 2, which is negative 22, minus negative 8 times 1, so plus 8. And so I'm going to be getting negative 50, negative 42. I'm going to be getting, negative 42, negative, so positive 42. And then negative 22 plus 8 is going to give me negative 14. Alright, now what I can do is I can also simplify this to be, because I noticed 14 goes into all those, and I can pull out a negative 14 if I wanted to, but I'm going to go ahead and just pull out a 14, and I can get, so pulling out a 14, I get negative 3, positive 3, and negative 1. So there, that is a vector that is pointing in the same direction as my my binormal vector. So therefore, what I'm going to do is now just write out my equation, and again I'm going to use this as my vector, and then my point is from the top 1, 1, 1. So I'm going to get negative 3x minus 1 plus 3y minus 1 minus 1z minus 1 is equal to 0. And I get negative 3x plus 3y minus z is equal to 3 plus 3 gives me 0. Negative 1 times negative 1 is a positive 1, so that's going to equal negative 1. And again, your answer